Howdy. So this is the first Atomo project that we've made. It's LED control system, and it's using the big controller module that can do up to 8 of our modules. To start off, we prototyped it using just through-hole components, doing 2 RGB channels here. So that works something like this. So I can put this, the big module, into a small connector board, and this is being powered by ATX supply over here. And of course it's complete overkill for just powering up these 2 little strips, but just is convenient supply for getting the power we need. So you can see they power up, go through a sequence, and then start flashing. So that was the beginning. That was how we prototyped it. And then the next stage was making a printed circuit board, which I'll show you in a minute, to drive this whole thing. And the plan is to make a large, like a 800 millimeter square LED assembly. I've got 40 meters of LED strip that I got from the market in Shenzhen. So what you're looking at right now, it's an 8 module system hooked up to that same power supply. The 12 volt is going to the VN input on this board. We're not using the 12 volt input at all. And then the 3.3 volt is supplying the microcontroller and also the logic level. The 5 volt is not being used at all. And then we've got on this demo LED assembly, we've got 16 squares of RGB LEDs. And then we've got 2 touch sensors that have wire loops here and here that are being read off of the analog pins here. So let's power that up and show you what that looks like. So you can see the discrete LEDs on this screen because I've turned down the brightness. So when my hand approaches, right now it's about 6 inches off of the box. So when it gets closer, so if it's in the middle, it turns blue. If it's on one side, it'll go red, and on the other side, it'll go green. So that's the touch sensors. So with the big one, I think we can do a matrix of, say, like 16 different touch sensors and do some pretty interesting multi-touch gestures on the scale of a person, basically, which will be really fun. So this one right now is pulling about 1 amp. It's about 1 amp per pixel, more or less. I think it is somewhere between half an amp to 1 amp per pixel. And then the big one should be able to pull, so each of the modules can have up to 8 amps. So for the big one, we'll be able to drive pretty close to like somewhere between 4 to 8 amps per module at 12 volts. So it'll be a pretty good amount of power and a whole lot of light if we're driving it at full intensity. So I'll show you guys the card itself, just to give you an idea of what a Atomo I/O module might look like, especially one that self-made maybe. So this one I did the schematics up in KiCad, and we'll be sharing the interface module, the interface components for KiCad for the modules. So I've got, I don't know if you guys can read this, but basically it's a low side drive system using MOSFETs. So we've got the positive VN, and in this case I'm running 12 volt to that, and then we've got the 3 different pins on the module headers. So it's the PWM signal, and then 2 digital, so GPIO signals for each one. We could do potentially some interesting things with the ones that are on the PWM pin, but what I've found with testing is because our system's pretty fast, it's running at 120 megahertz, we can get some pretty smooth fading and everything between channels, even with, in this case, 48 different LEDs that we're driving discretely. And then I've pulled out I2C here, but I'm not using it currently. We've got ground 3.3 volt, and then the 2 ADC pins pulled out from the module connector. The ADC pins, I am running, I'll have to post up the touch sensor IC, but I'm running it as a, basically I've got a voltage divider on the proximity sensing. So each pin is actually sensing both proximity and touch. With this IC that I'm using, it senses both proximity and touch discretely. And so you can do some different voltage levels to sense which one is which in this case. So that's that project. Yeah, so in the front I'm using, so each channel is being driven as little 4 amp MOSFET that's pulling everything low. That's pretty amazing how far all this has come in the last 10 or 20 years. So yeah, so that's the LED driver project so far. I'll keep doing more. The big panel will be very interesting to do when I have time. So that's that. And yeah, so options for later on, we could potentially upgrade it. We could network it. We could connect it up to a Raspberry Pi pretty easily if we want to do some sort of connected interface there. We could use a Pi Zero to get Wi-Fi, or potentially we could hook it up to a module. Yeah, so that's, and the other thing that we could potentially do is do power over Ethernet to run some stuff. This one only does 13 watts right now, so it might be able to just barely drive this, but anything more than this, it would have a hard time. But that could be an interesting project as well. So yeah, so that's the LED driver project from Atomo, to show you how this works. So to show you, so this is the controller module that I use. So this is the big one. We've got 3 sizes right now. So like a big, medium, and small. They're all based on the NXP Kinetis line. So this is a K22, which is ARM Cortex M4, and these two are both based on the K64, which is the same basic ARM Cortex M4, but this one has networking, which is how you can add these to it. And you can't add the networking directly to the small one, but you can interface it to Raspberry Pi. All right, so that's the LED driver project so far. Give you guys an update pretty soon. Thank you. Bye.